So we're going to be talking about different ways to solve quadratics over the next, I think, like 3 or 4 lessons. And a couple of them are a review of things that you would have done in Algebra 1, but I realized that Algebra 1 was virtual for you guys. So I want to actually take the time to teach this as though you had never learned it in Algebra 1. Things that are important to talk about when we're solving quadratics, but also when we start solving other types of graphs and equations in later units. Solving, what it actually means is we're finding the x-intercepts. So even if we're not actually graphing these things, that's what we're finding in these scenarios. So one thing I do want to point out is that x-intercepts have a lot of different other names. They're also called solutions and zeros and roots. And those words get used interchangeably all the time on SATs and SOLs. So think about which of these words makes the most sense to you, and then whenever you encounter one of these, always just change it. Me personally, I'm a very visual person. I like to, in my mind, think about what an x-intercept looks like. It's where a graph crosses the x-axis. So whenever I see one of these other words, bless you, whenever I see one of these other words, I actually cross it out and I put x-intercept instead. So that's a good strategy, especially if you are taking something like the SAT. But just to give you a visual of what we are finding, if we think about these different types of graphs, I have this Desmos graph that I'll go ahead and put up in Schoology as well. But I just have an example of a parabola. It doesn't matter. But these are the different quadratics we were graphing last unit. We're going to be studying them this unit as well. And what we're looking for when we find solutions is we're looking for where the graph crosses the x-axis. So in this case, you can see it has 2 solutions. It's crossing in 2 different spots. But we might have a parabola that doesn't cross the x-axis, or we might have a parabola that only crosses in 1 spot. So we'll talk about how to solve using the quadratic formula. Are there any questions for me so far? And the reason why I put stars next to this is just because these words get used interchangeably. So just make sure you're comfortable picking one that makes the most sense to you and just always replacing with that. All right. Because the quadratic formula involves a lot of substitution, I'm going to do color coding. We're going to look at just 3 examples, and I'm going to try and fit them in columns so we can kind of compare them. Is that going to work? Yeah, I think that should work. All right, and the quadratic formula is something that you don't have to memorize. It'll be on your formula sheet for the SOL and the SAT. So when we take our test, I'll have it on the board as well. That way you don't have to memorize it, you just have to be comfortable using it. And even though it looks scary, a lot of the things involved in it are things that you've done before. We've worked on identifying A, B, C in a quadratic, stuff like that. The important thing is you want to make sure your equation is in standard form, which means all the terms need to be on one side of the equal sign. Notice that this is not the case here. And in general, you always want to leave the x squared where it is and bring everything else to it. So how would I move this 6x to the other side of the equal sign? Yeah, exactly. It's just think about inverse operations. So we're going to subtract. I'm noticing that it's not a like term with either of these, so I'm just going to write out my new equation, making sure that I'm putting it in standard form. So starting with the biggest exponent and making them count down after that. Questions from me so far? All right, so if I start to identify A, B, and C, those are always just the coefficients for each of my terms. So for example, A in this scenario would technically be 1. So go ahead and quiz yourself, see if you can find B and C. So B would be -6, and C in this case would be 2. Questions for me so far? All right. Yeah?
Will the ABC number correlate to what exponent it is? Will it always be x2?
Yes. Yeah. So A is always going to be for the highest exponent in this case too. Yeah. Good question. Yep. So for the substituting into the formula part, if you're someone like me if you have, if you make small mistakes with like the signs of stuff, if you leave those off, what I would recommend is just go through and write the formula and leave empty parentheses wherever you see a variable, and then you'll just go fill it in afterwards. You don't have to do it that way, but I found that that makes it less likely for you to make a mistake. Minus 4ac. So all I'm doing is I'm going through and I'm writing this exact formula, but anytime I get to one of these variables that I'm replacing, I'm just leaving empty parentheses. And then once again, if you're a visual person, you could even go through and start to highlight those parentheses so you know exactly what's going to go inside of them. So we're substituting into our formula. So anywhere I see pink, that's going to be my A value. That'll just be a 1. Anywhere I see orange, I'm going to put a -6. And anywhere I see yellow, I'm going to put 2. Questions for me so far? You can actually start simplifying now. So if I think about order of operations, I'm supposed to do what's inside of grouping symbols, and my grouping symbol here is actually this square root sign. So I'm going to start with everything inside of there first. So I'm noticing that -6 squared, what is that going to give me?
36.
Okay. And I'm also noting this minus a negative. I can go ahead and just change that to a +6. So I'll have +6 plus and minus. -6 squared is 36. And then -4 times 1 times 2, that's going to give me -8. And 2 times 1 will just be 2. So any questions so far? All right, so if I keep simplifying, I'm noticing that 36 minus 8 is going to give me 28. Questions for me? All right. If I think back, 28 is not a perfect square. It wasn't on that list of perfect squares that we made, but we can simplify it further. So if I just show that off to the side, could you take a little bit of time and figure out what is the biggest perfect square that fits into 28? 4. Yep. So if I rewrite this as the square root of 4 times the square root of 7, that's the same thing as 28. So I'm just working on simplifying it further. The square root of 4 is just a 2, and that'll be root 7. So even though 28 is not a perfect square, I can go ahead and simplify this a little bit further. So I would say 6 plus or minus. Instead of root 28, I'm going to write it as 2 root 7. We simplified that radical. And I have it divided by 2. Questions for me so far? All right, I'm noticing I have 2 different terms. I just want to check, can I divide both of them by 2? If so, I can simplify this further. So in that case, if I can divide them both by 2, what is that 6 going to become? So that'll be a 3.
Wait,
Oops, sorry.
The root 7 can't be.
But think of this like if I have 2 x's and I divide by 2. So if I have 2 root 7s and I split them into 2 groups, each of them is just going to have 1 root 7. Does that make sense? Okay. And I know that the square roots are still kind of tricky. So when you are stuck on a situation like that, since you guys are pretty good working with variables, I would just change it to 2x and think about, can I simplify that? Oh yeah, that's going to be 1x. So that's my clue. Okay, that's just going to be 1 root 7. Yeah. So while you're learning new things, the more you can relate them to something you already know, the easier it'll start to become. Okay. Because for our test, we're not going to have calculators, this is as simplified as you'd be able to make it. So we're going to leave our answer here for now. But for the purposes of giving you a visual of what we just found, I am going to go ahead and use my calculator and show you the decimal answers that I would get for this. Yeah.
If the 2 goes into the 2, why don't you call it a 1?
You could. So technically this, yeah, a coefficient in the same way that if I were dividing 2x by 2, I have 1 x left over. I wouldn't normally put a coefficient of 1, but you can. So in the same idea here, I have 1 root 7. I can put a 1 in front of it to show that. Absolutely. So I would normally, you'll normally see like on an SAT, the question would be like this, but if you wrote a 1, it would be the same thing. Yeah, good question. Other questions for me? Okay. So since what we're finding is the x-intercepts, the solutions to the equation, there's actually 2 of them here. What this means is if I were to actually take this further with my calculator, I would take 3 and I would add it to root 7, and I would take 3 and I would subtract root 7. And so I'm going to go ahead and do that in my calculator just so I can show you visually on a graph why these are the solutions. So if I do 3 plus root 7, that's going to give me approximately 5.6. And if I do 3 minus root 7, that's going to give me approximately 0.4. So we're going to look at this graph now, and we're going to see that it crosses the x-axis in 2 places, at about 5.6 and at about 0.4. But once again, for the test, since you won't have a calculator, you could just leave your answer here, but visually I want you to see why these are the solutions. Any questions from me so far? Yeah?
So we would just do that as x equals 3 plus minus 7.
Yep. Or if it made more sense to you, you could write it as 2 separate things, 3 plus root 7 and 3 minus root 7. Exactly. All right, so I'm going to pull up that Desmos graph. Like I said, I'll have it on Schoology later just so you can kind of reference it. But the equation that we just worked on is this one. And notice that it's crossing the x-axis here at 0.35, which was one of the ones that we had. And it's also crossing here at 5.64, which was the other one that we had. So questions for me about that?
Well, I probably had 0.4.
Oh, I rounded it. It was 0.35, but I rounded it to 4. Yeah. All right. Questions for me? Okay. So I'm going to have you guys try one now. So you're going to start out by putting the equation in standard form. Sometimes they will be, but I wanted to make sure we're practicing how to put it in standard form. And in general, leave the x squared where it is, so you're going to need to move these other 2 terms over.
Just add both.
Yeah, exactly. They're negative.
There are no like terms, so you just gotta make a positive on the other side.
Exactly. So they'll just kind of be stacked together. Sorry, that's a 16. So we'll have x squared plus 8x plus 16 equals 0. So it's in standard form now. So you're going to work on finding a, b, and c and plugging it into the quadratic formula. All right. I'll walk around, so if you have questions or want help, just let me know.
It should be a positive x, right? It wasn't just on that side.
Oh, right.
Yeah.
Oh, sorry. That was because we're trying to get rid of this. So we're adding 16. And then whatever we do with it equals 4. That's actually just a 16 and 16. We'll be there in a second. So this word is 0. So that usually be minus. If I add 0 with -8, I subtract 0
Oh, yeah, you're right. What is root 0?
0. What number times itself gives you 0?
0, 0.
Yeah.
Okay.
So inside the root equals 0.
What?
0. So it's going to just be -8 plus 0.
Wait, yeah.
And it's S minus.
Where's the x come from? 8x. Do I leave it out? Just, yeah, the coefficient things.
That was actually shocking.
There.
Because you do -8 plus 0, -8 minus 0 is so much -8. So it's -8 divided by 2. Calculator.
This is all I do, right? Oh, yeah, right.
No, so this means 0.
It's like a world map.
Amanda, what's wrong? Stay tired.
Yep. All right, take a little bit of time to start checking in with your shoulder partners. I'm going to call on people for different steps of this in just a moment.
No. That is true. Wait. Yeah.
You don't have to be on the bus anymore.
Oh yeah, I heard.
Yeah.
You're going to bus 13 now.
This is tragic. Yeah. What answer did you get? Why not?
All right, so Knox, can you tell me what did you end up with A, B, and C in this situation?
I got A, 1 for A.
Yep.
8 for 16%.
Good. So any questions for me about how to figure out where A, B, and C are once you have it in standard form?
You just put them in.
Okay, so in that case, all I'm going to do now is just start to substitute in. So wherever I have A, I have a 1. Wherever I have B, I have an 8. Wherever I have C, I have 16. So as I start to simplify, I'm noticing this is going to be a -8. What is 8 squared going to give me?
64.
Okay. And what happened when you had -4 times 1 times 16?
-64.
Okay. And if we take that one step further, that's going to give us 0. What is the square root of 0?
0.
It's just 0. So this is one that, as you're working through it, if we add or subtract 0 to -8, it doesn't change the value. We just have -8. So you only end up with one solution in the end. And that will happen sometimes. So I'm going to show you kind of visually what that looks like on the graph. Any questions just about getting to that point? Okay. So I'm going to pull up the Desmos graph. Once again, I'll have this on Schoology later if you want to reference it. But the one that you just graphed, or just found the solution for, is this. So basically what that means is if you have one solution, it just means the vertex is on that x-axis. That's all. Questions from me about that? And things to think about, if this A value were negative, all that would mean is that my graph would be upside down, but it would still be touching in the same spot. Okay. So, last one that we're going to do. All right. Notice this one you don't need to rearrange. All of our terms are on one side of the equal sign, so it's technically already in standard form. But notice it's missing one of those values. So take a little bit of time, write out what you think A, B, and C are going to be. So yeah, one of these is going to be 0 because one of them is missing, so just be careful about which one is missing. All right. So what is the A value in this scenario? All right, so it's -6. What is the B value? So that's the term that's missing. So it's just going to be 0, and then C would be -6 as well. Questions about getting that far? All right, so if I start to substitute into the formula, all right, so if we start to simplify this, can 0 be negative?
No.
So that's still just going to be 0. 0 squared is just 0. What happens when we multiply -4 and -6 and -6? Okay. So we'll have 0 minus 144, and then 2 times -6 is going to be -12. So if I take that a little bit further, 0 minus 144 is -144. And think about the fact that we just worked on imaginary numbers. Imaginary numbers help us simplify square roots that are negative. If this was positive 144, I could take the square root of that. That would just be 12. So it might help to take a little bit of time, maybe even off to the side. Think about how you would simplify that. What would that look like? All right, so if I think of this as the square root of -1 times the square root of 144, what is the square root of 144 going to give me? So that'll be 12. And how do we represent the square root of -1? Yep.
What did I tell you? Talk to me.
When we take the square root of a negative, it's going to be imaginary.
Yeah, talk to me.
Okay, questions so far? All right, what's going to happen when I add 0 to this 12i? Okay, so what this symbol means is that we have two answers. We have a positive 12i and a negative 12i. So that's what that means. So we basically have to split this up into two possible answers, where we're taking positive 12i and we're dividing it by that -12. And then we're also taking negative 12i and dividing it by -12. So my solution to this one is going to be -i. My solution to this one is going to be positive I. So I have two imaginary solutions. Questions for me so far?
For the test, do we just need plus minus 12i over -12?
So you do have to simplify completely. These are divisible, so you would have to show me what the answers are, the simplified answers. Yeah, good question.
-1. Wait, we have to show both the answers?
Yes. You could write your answer as positive and negative I. You could write it like that. That's fine. Those mean the same thing. But you would want to simplify completely. Yeah.
What did they write if we put like x equals -I and x equals I?
That's right. Yeah, that's totally fine. So what this would look like visually, I'm going to pull up a graph so you can see. This is the one that we just solved. It would look like a graph that's not crossing the x-axis in two-dimensional space. But we saw in that video, if I were to look at this in three-dimensional space, if I could create another axis that's coming out this way, this is crossing, it's just crossing in three-dimensional space. So anytime you get an imaginary answer, that's what it means, is it's just crossing in three-dimensional space. Questions from me about that? Yeah?
Is it possible for one of your answers to be imaginary and one of them to be real?
Good question. These are examples of like all the types of scenarios. So to answer that, we're either going to get two real answers, two imaginaries, or just one.
Or an hour.
Exactly. We're not going to have one of each. Yeah. Questions? So they always come in pairs. They're either both real, both imaginary. Other questions for me? That was a good one. Okay, so the very last thing that we're going to talk about today is related to what we just did. I've kind of run out of space, so I'm going to flip over in just a minute, but if you need anything else from this, I can leave it here for a moment. No.
I thought the second thing we were doing was our test.
We are going to go over the test, but we have to talk about something called a discriminant.
Do you think this is enough already?
I think so.
Last time you said that. I had to take that.
I hate like doing most of the page and then just like a tiny.
A little tiny sliver left.
You can't like erase it.
Right. All right. So the last thing we're going to talk about today is the discriminant. And this is, it's the part of the quadratic formula that tells us whether we'll have two real solutions, two imaginary solutions, or one solution. I guess one real solution. So in the examples that we just saw, we started with an example that had two real solutions. The second example had one real solution, and then the last one had two imaginary solutions. So I'll give you a little bit of time to write this down. Don't feel rushed. The person who made it each day is adding a new little picture. And it's just the school days. It's not the weekends.
Until winter, right?
Yeah.
We only have like 20.
I know, isn't it crazy? So the part of the quadratic formula that tells us what kinds of solutions we're going to have is actually just the part that's underneath the square root sign. So the discriminant is that b squared minus 4ac. It's the part that's under the square root sign. So basically, if the discriminant, if b squared minus 4ac equals a positive number, then that means we're going to have two real solutions. I think it'll be fine. Yeah.
Just make your lines really.
Yeah. So if your discriminant came out to be a positive number, that's going to end up giving you two real solutions. And that's basically like example A that we did before. And I'll flip back in a moment just to show you. Actually, I can just use this. So when we did example A and we were simplifying what was underneath the square root sign, we got a positive number there, and we ended up with two real solutions in the end. So what's underneath the square root sign, if it's a positive, that means you'll have two real solutions. And visually, what that would look like on a graph is that we saw it on Desmos. It's basically just a graph that crosses the x-axis in two different spots. So those would be my solutions. Those are my x-intercepts.
Could it be going either way?
Yeah, so it could be upside down instead, and it would just cross in two spots. Exactly. Good. If my discriminant is a negative number, or sorry, let's say if it's 0, just to go in the same order that we did it before. So if it works out to be 0, that means that we're going to have one real solution. And that was like example B before. And we saw that visually on a graph, what that ended up looking like is it was a parabola that just crossed or touched the x-axis in one spot at the vertex. And so that could be one that's upside down, or that could be one that's right side up, either way. All right, and we saw that on the previous page. This was the example that we did. And so when we ended up with 0 in there, we basically ended up with just one solution in the end, one real number. If your discriminant, if what's underneath the square root sign comes out to be a negative number, as you're working through the quadratic formula, that's your clue that you're going to have two imaginary solutions. And so that was like example C that we just did. So that'll be one, so you have 5 minutes. That'll be one where it looks like it's not crossing the x-axis at all in 2-dimensional space, but it is crossing in 3-dimensional space.
Wait, can you go over a little bit to the first one?
Mm-hmm. All right.
What is under the root mean?
So if I look inside the quadratic formula, b squared minus 4, you see that's the part that's just inside the square root sign.
Oh.
Yeah. Sorry, I could have said inside. Inside or under the square root sign. Okay. So, what are some questions you guys have for me? Okay, so we're going to go ahead and stop this lesson here. We're going to go over your test.